Here's our agenda today. First, we'll go over serial communication in general. I'll give you some details on RS-232, RS-485, and RS-422. Then we'll go over some applications. Then we'll go over some of the products which we offer. Okay, thank you. Okay. Okay, so again, here's our agenda. First, we'll go over serial communication in general. Then we'll go over some applications, some serial port converters that we offer, as well as Ethernet to serial converters and programmable serial converter solutions. ICP DAS was established in 1993. Our headquarters is in Hsinchu, Taiwan, and ICP DAS USA was launched in 2001 to support North and South America. We're ISO 9001, and we're also a Windows embedded partner. The EIA 232 interface standard was developed for a single purpose of interfacing two equipment employing single binary data interchange. EIA 232 was originally named RS-232, where RS stood for Recommended Standard, which is still in popular usage today. The prefix RS was superseded by EIA-TIA, which stands for Electronic Industries Association / Telecommunications Interface Association in 1988. It should be emphasized that RS-232 and other related EIA standards define the electrical and mechanical details of the interface, layer 1 of the OSI model, and does not define a protocol. The RS-232 interface standard specifies the method of connection of two devices, the DTE and the DCE. DTE refers to the data terminal equipment, for example, a computer or a printer. A DTE device communicates with the DCE. The DCE, on the other hand, refers to the data communication equipment such as a modem. The RS-232 standard consists of three major parts, which define electrical signal characteristics, the mechanical interface, and the functional description. RS-232 defines electrical signal characteristics such as voltage levels and grounding characteristics of the interchain signal and associated circuitry for an unbalanced system. For the mechanical characteristics, RS-232 defines the mechanical characteristics of the interface between the DTE and DCE. This dictates that the interface must consist of a plug and socket, and that the socket will normally be on the DCE side. The common data transmission rates used for RS-232 are 110, 300, 600, 1200, 2400, 4800, 9600, and 19200 BPS or baud per second. For shorter distances, however, transmission rates of 38400, 57600, and 115200 can also be used. Based on field tests, it can be shown that much longer cable lengths are possible at lower baud rates. Note that the achievable speed depends on the transmission voltage and cable capacitance, as well as noise in the environment. In spite of its popularity and extensive use, it should be remembered that RS-232 interface standard was originally developed for interfacing data terminals to modems. In this context, the modem requirement has several weaknesses. Most have arisen as a result of increased requirements for interfacing to other equipment such as PCs, digital instrumentation, digital variable speed drives, power system monitors, and other peripheral equipment in industrial plants. The main limitation of RS-232 is that the communication and control equipment in the industrial environment are restricted to point-to-point. This limitation allows, I guess, equipment not to be considered smart. The distance limitation of 15 meters end-to-end is too short for most control systems. The baud rate is too slow for many applications as well, and that has to do again with cable length as well. The -3 to 25 volts and the 3 to 25 volt signal levels are not directly compatible with modem standards and power supplies. Consequently, a number of other interface standards have been developed by the EIA which overcome these limitations. The RS-232 or EIA 485 interface standard are increasingly being used for instrumentation and control systems. The RS-485 standard is one of the most versatile of the EIA interface standards. It is an extension of EIA 422, or better known as RS-422, and allows the same distance and data speed, but increases the number of transmitters and receivers permitted on the line. EIA 485 permits a multi-drop network connection on 2 wires and allows reliable serial communication. The maximum bit rate and maximum length can, however, not be achieved at the same time. For 24 gauge twisted pair cable, the maximum data rate at 4,000 feet or 1,200 meters is approximately 90 kbps. The maximum cable length at 10 million BPS is less than 20 feet or 6 meters. Better performance will require a higher grade cable and possibly the use of active solid-state terminators in the place of the 120 ohm resistors or repeaters. The RS-232 is still available in many legacy and newer equipment, as it is easy and low cost to implement. In industrial equipment like PLCs, PACs, and remote I/O devices from ICP DAS, most come standard with RS-232 or RS-485 interfaces. Barcode readers, laboratory equipment, and other serial devices connect using these ports to our equipment. The I-7520 is usually used to connect a PC or PLC which has an RS-232 port to equipment for RS-485. It can also be used to extend the distance between 2 devices with RS-232 by converting to RS-485 on one end and then converting back to RS-232 on the other end. The self-tuner feature makes it plug and play. No baud rate settings or driver installation is required, and it will adjust the baud rate depending on the data transfer rate on the input. The I-7520 has isolation feature to protect either the PC or PLC or the RS-485 network, depending on how the converter will be powered. The user can select the proper module to ensure isolation. Note that the I-7520 is isolated on the RS-232 to RS-485 side, and the I-7520A is isolated on the RS-232 to RS-422/485 side. And the R versions transfer the isolation to the other side. The TM7520U is a smaller form factor than the I-7520. Another important distinction is that the baud rate can be set by a dip switch or it can be used with the auto baud/self-tuner. The benefit of selecting the baud rate instead of using the self-tuner is when working with longer distances or noisy environments. Here's an example of a TM7520U application. The TM7520U is connected to an RS-232 port on the PC. Then it communicates to other devices which communicate by RS-45. And again, the benefit of RS-45 is you can daisy chain multiple devices and achieve much longer distances than standard RS-232. Newer PCs don't have RS-232 ports, but we offer I-7561, which communicates using the serial or USB port that's on these computers. The I-7561 and I-7561U for newer Windows 8 and 10 systems offer the ability to use USB 1.1, 2.0, or 3.0 ports. ESD protection for the RS-232, 422, or 45 data lines, and it's self-powered and doesn't require any additional power supply. It offers automatic RS-45 direction control and is DIN rail mountable for industrial applications. The TM7561 is a similar solution. It is also USB powered and requires no additional power supply, and it's a much smaller form factor and cost effective. This one is only RS-485 though. The previous solution was RS-232, RS-485, or RS-422. The TDS700 series is our line of serial to Ethernet converters. These are used to use an Ethernet port either directly connected to the PC or going through routers and switches to connect to RS-232, RS-422, or 45 devices anywhere along the network. Using our VXCOM driver for Windows systems, it will be recognized as a virtual COM port on your PC, and you can communicate to a device halfway across the world or across your plant as if it were connected directly to the computer. And it offers the feature of either being PoE, meaning power over Ethernet, or you can power the module through a DC jack. And it does support pair connections so that you can do either a serial bridge or serial tunnel or Ethernet bridge or Ethernet tunnel through wiring. Here's an example of the TDS application. Note on the left side of the PC running the virtual COM port. So devices connected to the top TDS 700 series, for instance, would be connected to devices considered COM1, and the TDS at the bottom or in the middle would be connected to COM2 for the power meter and for the i7000 series. And each of the different TDS or COM ports would be communicating in different protocols. The top one being our Modbus RTU modules, the bottom one using either just standard RS-45 serial strings or our DCON protocol. And the bottom picture shows a PLC connected by RS-232 to a TDS-700, and it's configured in pair connection so that anything that comes in through the RS-232 connection from the PLC goes through to the instrument at 115/200 baud rate to the instrument. The 7188E series are embedded controllers defined to meet the most common requirements of Internet and Ethernet applications. They can be used to replace the PC or the PLC in harsh equipment When linking these devices together, users must write a program to read or write to the 7188. In general, though, it runs our VXCOM firmware, which allows you to do applications very similar to our TDS modules. It does allow for more communications, so you can connect multiple TCP device or TCP connections to those specific serial connections. So for instance, for Modbus networks, if you had multiple masters and wanted to connect to the slave devices, you could, because the TCP connection allows for multiple connections. The communication to the Modbus RTU devices will be buffered and will be passed along sequentially based on the firmware. Here's a list of some of the variations of the 7188E, which offer different combinations of RS-232 and RS-485 ports. Each one will be recognized as a different virtual COM port on your PC. So for instance, for the i7188E3, that module has one RS-232 port, one RS-485 port, and one RS-422 port. So you can create 3 different COM ports on your PC for each of the different connections, or one for each of the different connections. Here's a sample application that has been implemented or is in the manual. The PC in the top left corner connects by Ethernet to a hub and then goes through a router and then goes to the internet through another router to a hub, and finally winds up at a 7188E, which has an expansion board and has devices connected to the COM ports. The expansion board allows for you to control I/O, so meaning you can turn things off, turn things on, like through Ethernet control, and you can also communicate to the RS-232, 485, or 422 devices on those specific virtual COM ports. The PDS 821 allows you to install multiple communication cards. I'll show you a list of the cards in the next slide, but it has 2 I/O expansion slots that you can mix and match the different variations of or different combinations of port types. And this one can accept up to 2 cards each for a maximum of 8 ports. I lied. Next slide. I'll show you the example of the combinations. Here's an example. Let's see, the COM port program itself runs in the PC. So again, it just creates different virtual COM ports for the different devices. You can also do pair connections using the PDS 821. Here's a look at some of the modules, what they look like. The i8112 has 2 9-pin DB9 ports for RS-232 connections. And the next 2 modules have screw terminals and a larger DB connector for ease of wiring. Okay, finally, here is the different variations of the slot modules which will plug into the PDS 821 to give you the various combinations of COM ports. So now we have cards which will have 2 RS-232 ports, 4 RS-232 ports, 5-wire RS-232 ports, and RS-422 and 485 ports. If you need more details, those are also in the product manuals. That's all I have for you today. If you have any questions, please feel free to type it in the chat box, and we'll get those questions answered for you. Let's see, so far I'm not seeing any questions. Okay, if you do have any questions at a later date, you can contact us using any of the methods shown. You can also follow us on Facebook, Twitter, and we have a YouTube channel that you'll be able to view this video. Thank you for attending, and we'll see you next time. Thank you.